So this is October 14th. We are going to talk about how to calculate the p-value for we'll start off with the chi-square distribution, but we'll circle back to the t distribution and the x distribution as well. The problem right now at hand is if you are testing a hypothesis regarding variation, of course you use the chi-square test statistic. And for the problem at hand, we have a test statistic value for chi-square being equal to 0.852. And it's going to be a left tail test. So to calculate the p-value, we want to find the area that's under the curve from negative infinity to 0.852 for chi-square distribution with 9 degrees of freedom. We're going to go into the distribution menu, and then we're going to go down to option 8, which is chi-square CDF. You remember what CDF stands for? Anybody? Cumulative distribution function. So this command is going to add up the area under the curve between the lower limit and upper limit. Now, I, over the weekend, updated my version of the TI-84 software. So a lot of the more modern TI-84s will have this sort of interface in doing the CDF functions. Now, the lower limit will be at 0. I said negative infinity. It's actually 0. And the upper limit's going to be our test statistic value, 0.852. And then you're going to put in 9 degrees of freedom. So go ahead and do that for me. Follow these commands. I'll give you a minute for chi-square CDF. And when we paste that onto the home screen, this is what it looks like. If you have an older version of a TI-84, then when you execute the chi-square CDF, it's just going to give you chi-square CDF with an open parenthesis, and then you have to manually plug in the left limit 0, comma, the right limit, which is the 0.852, comma, and then the degrees of freedom, which is 9. Close parentheses and hit enter. And notice that our p-value is about 2.9 times 10 to the negative 4th power in scientific notation, which is a rather small value. Now, somehow the author of the textbook was able to use what they're calling an S-squared test. Well, I could tell you that on our calculator here, as you scroll through the tests, there's different ways of doing your intervals in your various tests. And if you were to pull up the chi-square test, option C, we're going to come to this one, but this one is not for the chi-square test that where we're testing claims about the standard deviation. So we're not going to use this one. So if that doesn't work, then what does? Well, if you pull up the chi-square goodness of fit test, well, that's not it either. So the short answer is there isn't one. So when you're looking in the textbook and you see the S-squared test, I don't know. You might have it under apps or something. So you might want to explore around your graphing calculator to see what you have. But I certainly don't have it on mine. Okay, but I showed you how to use excuse me, of how to use the CDF function, how to calculate the area under the curve, under the null hypothesis, and that's going to be your p-value. And notice on the PowerPoint, you can't see it right now, but it says p is equal to 2.897435436 times 10 to the negative fourth power versus my calculation of 2.904283221 times 10 to the negative fourth power. And the reason for the difference is that I am just using the rounded off value of the test statistic 0.852, whereas for the S-squared test that you might have seen in the PowerPoint and in the textbook, you would actually input all the data into your calculator, and the calculator would generate for you. All right, so we have a p-value of 10 or 2.9 times 10 to the negative fourth power, and you compare that against alpha, which is 0.01. And our p-value is less than 0.01. So we would reject the null hypothesis. Okay. Now, while I'm at it, I wanted to show you p-values for the t-distribution as well. And this goes back to testing hypothesis for the mean. And you go down to option 6, which is the t-CDF function. And if you're doing a left-hand test and you want to find the area under the curve between negative infinity and a particular t-value, then you would just plug in that t-test statistic value here for upper, and then the degrees of freedom, which is the sample size -1, and then you would plug in paste and execute it, and you would have your p-value that way. But I would encourage you, though, that if you want to use your calculator to test claims, about the mean, I would encourage you to use the, go into your stat menu, test, and just use the so-called t-test. This is for the material section 8.4. in which you would either use data that you've uploaded or that you've already have pre-existing statistics. Okay, and just use this one. I showed you how to do this on a previous video. Okay, now someone was asking me yesterday of how to do critical values. Now, regarding the chi-square, I don't know of a way of getting critical values here. You'd have to do something like a chi-square inverse, which we don't have on this calculator. As you scroll through your various distribution options here, you don't see a chi-square inverse. Okay, so you have to use the table to get your critical values. But if you don't have access to a t-table that's full-blown, and instead you have maybe a stripped-down version like you've got in this textbook and what I've handed out to you, you could calculate p-values for your t-distribution. Even if you don't use that t-test on your calculator, you could still calculate t-critical values. And to get your t-critical value, you use inverse t, which is option 4. And you need to tell it the area under the curve to the left. So if you have a left-tailed test with alpha is equal to 0.05, then you plug in 0.05. The area stands for the area under the curve to the left. And then I have to tell its degrees of freedom, which is sample size minus 1, whatever it is, and then paste. And then it'll tell you the critical value, negative 1.833 in this case. Question, Joe?
That only works with areas on the left.
Yes, that's for the T. For the T curve. Now, if you want area under the curve to the right, then you subtract from 1. So if you have a right tail test of alpha equals 0.05, then you go to inverse T, and then you put in 0.95. And then you have positive 1.833. Okay. Now, if you have a two-tailed test with alpha is equal to 0.05, that means that you have 0.025 in the left tail and the right tail. And so you would 0.025 for the left tail and paste. And then you'd have negative 2.262 as the left critical value and positive 2.262 for the right critical value. And same thing with the normal. If you don't want to look up in the Z table to get your critical value for the Z distribution, you can use the inverse norm, which is option 3, to get your critical values for the normal distribution. You're going to recognize this one. If we have critical, level of significance of 0.05 with area under the curve to the left of 0.05, so a left tail test, then you plug in 0.05 for your area under the curve to the left. And then you need to say what your mean and standard deviation are for the distribution. Suppose it's just a standard normal. And there you go. Negative 1.644 or negative 1.645 would be your left critical value. And that's for a left tail test with alpha equal 0.05. Or if you have a two-tailed test with alpha is 0.05, then you just do inverse norm. And area under the curve would be 0.025. And you plug in mu and sigma and then paste. And then your left critical value would be negative 1.96, which should sound familiar, huh? And if it's a two-tailed test, then your right critical value would be positive 1.96. Okay? With that said, are there any questions about how to get critical values and how to calculate p-values using your graphing calculator? All right, play around with this. If you have more questions, of course, you're always welcome to see me, but you could always Google it. Of course, knowing how to ask the right questions is important as well. But, if you're curious about how to find a p-value for the chi-square using your graphing calculator, you could just go into Google and input as a search set of terms of, how to find p-value for chi-square test statistic using the TI-84. Something like that. Or how to find the area under the curve of the chi-square, CHI dash SQARE, using the TI-84, for example. Or how to find critical values with the T distribution with the TI-84 calculator. That sort of thing. And there's lots of videos and step-by-step instructions that many people have posted through the years. And you'll have a lot of resources on the internet. Okay? So with that, I'm going to end this recording.